Okay, the next topic we're going to discuss is something known as dummy variables. They can also be called indicator variables, and they're just categorical variables with two levels. So you can think of them as yes, no, on, off, male, female. And so we're going to code these up as zeros or ones. So for example, we could assign the value yes to 1 and the value no to 0, something like that. And so when we are analyzing dummy variables, what we're doing is we need to assume that the slopes associated with the numeric explanatory variable do not change with the value of the categorical variable. And we'll explain and visualize what that means here in a moment. So let's just jump into an example. Let's go back to our example from the last chapter. If you recall, we were looking at gas mileage and horsepower. So now let's just add one extra variable. So we have beta naught plus beta 1 x1 plus beta 2 x2. So that's estimated miles per gallon. So mpg hat plus beta naught, or equals beta naught, plus beta 1 times horsepower, plus beta 2 times man. So man, I'm just saying is an indicator or a dummy variable for manual transmission. So just defining these, so y, again, is miles per hour. That's our response variable. Our first explanatory variable, x1, is horsepower. And now I'm saying x2 is something called man, or I'm just abbreviating for manual transmission. So let's say it is equal to 0 if automatic transmission and let's say it's equal to 1 if manual transmission. So we have two variables for transmission. It's either automatic or manual. And yeah, I can choose it however I want. I decided to say 0 for automatic and 1 for manual. So when we think about our miles per gallon and horsepower, remember our regression line was negative sloped. It was something like this. But now we added this dummy variable. And so we actually are going to have two different lines with the same slope. So let's visualize this for a moment. So let's take manual to be in blue. So actually, let me draw it a little lower. So I'll say blue is manual, and then I'll take red to be automatic. Okay, so let's think about what these regression lines would look like. So for manual, we would have y hat, or miles per gallon, is equal to b naught plus b1 x1, that's for horsepower, plus b2. Well, let's look at this. So this b2 times manual, or b2 times x2, right? It's equal to 1 if it's manual. And we're talking about manual right now. So b2 times x2, well, in this case, it'll just be equal to 1. Because we're saying x2 is equal to 1 if it's manual. It's equal to 0 if not. And so if we were to just rewrite this, we would have something that looked like b naught plus b2, because b2 times 1 is just b2, plus b1 x1. Actually, let me just put some parentheses around this. Okay, so now let's do the same thing, but for automatic. So we would have y hat is equal to b naught plus b1 x1, or horsepower, plus, but now for this, we're now plugging in 0 for manual. So 0 for x2. So it's now b2 times the value 0. So we would say plus b2 times 0. Well, anything times 0 is just 0. And so we would then simplify this to just b naught plus b1 x1. So when we do that, we can see that they have the same slope, right? b1 x1, same slope. However, they have a different intercept. Different intercept. So let's go ahead and write that. So the intercept in red, or for automatic, is just b naught, right? So this value right here is b naught. That's the y-intercept. But now for for manual, it's b naught plus b2. So that means this value up here is b naught plus b2. And so we can see that they have the same slope because these two lines are parallel to one another. They just have a different y-intercept. So we're saying that the effect of horsepower on miles per gallon is the same for both manual and automatic transmissions. We're just saying that overall manual transmissions get better gas mileage by an amount of B2 because the difference between these two lines at any given point, right, from here to here, that value is always going to be equal to B2. So let's go ahead. Let's give this a number. Let's just say B2 is equal to the value 5. So that would be 5 miles per gallon. So if we were to give an interpretation, so B2 interpretation, we would say, on average, gas mileage for manual cars is 5 miles per gallon higher or greater than automatic cars given the same horsepower. Right, we have to compare apples to apples here. So we need to say, so if we're looking at this point here, right, if we wanted to say for particular horsepower, so for this horsepower, right, this difference here would be 5 miles per gallon. So for the same horsepower, automatic or manual cars should get about 5 miles per gallon better than automatic. So if we just wanted, say, a general dummy coefficient definition, so we could say on average, y is b dummy. So in this case, that would be b2 because our dummy variable is b2. So that would be this up here. So b2 times x2. That's all I'm saying. So b dummy would be b2 is greater than or less than in the x dummy group equal 1. So in our case, manual. Than in the x dummy equals 0 group. In our case, automatic. Given the same levels in all other explanatory variables. So on average, one group is greater than or less than the other group by the beta coefficient, which is just the difference in the y-intercept. And that's how we would interpret the dummy coefficients.